Hello pre-calc friends! This is an introduction video for a project from section 6.5 with trig inverses, and I bring this back from year to year because it's kind of a neat project that ties everything that we've been doing with trig inverses. This is a cool project that relates agriculture with temperature. So what you're given here in this red box is a really handy equation for T in terms of X. T is the temperature. T is the average temperature in degrees Fahrenheit, and the X here is the day of the year, the actual number of day of the year. And for that, go over down here to the chart, and these are all of your X values. What this does to help you interpret this graph, for example, the day of the month, if I look at January, the first day of the month would be X equals 1. What if I want to find the first day of the month in May? What day of the entire year is May 1st? And that is the 121st day of the year. One more example. How about, what is September 15th? What day of the year is September 15th? And if you look at the column here and the row here, September 15th is the 258th day of the year. And it kind of makes sense as you go further and further along the chart. You can see that we're getting closer and closer to the end of the year, which would be 365 days. That's why it looks like December 15th is really close there. So all these values here in the chart are X's. This is the day of the year. And when you plug in these days of the year, we're given this really neat equation up here that tells you what's the average temperature in South Carolina at that time of the year. So it's kind of cool. And this is because temperature is basically cyclic. You know, you have the seasons, so they come back regularly, so we can map it with a nice cyclical function like a trig. This one here is in terms of sine. So what you're going to do to walk you through it, in question number 1, let's just test out this equation. And they want you to test it out by just finding out what is the average temperature, what is T, on the 15th day of the year. The 15th day of the year is the same thing as January 15th, by literally taking the number 15 and plugging in for X into the equation up here. Now, a couple really important things. Make sure in your calculator, folks, that you are in radians. If you see the pi here, that's a really good indication that you should switch your mode to radians for this to work. So as you plug in, just keep working your way outside. Plug 15 in for X here in the equation. Then you're going to subtract 101. Then you're going to multiply by 2 pi over 365 in your calculator. And you're going to take the answer to that and take the sign of the answer button. And then multiply it by 25. And the last step is add 50 to your answer. And use a little bit of common sense. If you get something in the thousands, that's how many degrees it is. That would make sense, right? So something in January, so it should be something a little bit on the cooler side, right? So one of the, maybe an answer somewhere between the 20s and the 50s or so. And that's question number 1. For question number 2, why don't we use the chart, and they're asking you, can you find the average temperature, can you find T on March 1st and August 1st? So on March 1st, if you look in your chart, what X value is it when March 1st? That's the X value that you'll plug in, and you'll repeat basically what question number 1 says. For August 1st, if you look on your chart, what day of the year is August 1st? And you'll plug that into your equation up on top. That's question number 2. Now, question 3, 4, and 5 are basically the same thing, just 3 times. And they're kind of interesting when you read them, because based on the type of vegetable that the farmer wants to plant, depending on what season, he has to wait for a certain temperature to come up. You don't want to plant it too early or too late, or you're going to miss your crop and lose a lot of money. So for number 3, for example, whatever he wants to plant, he has to make sure that the outside average temperature is 45 degrees. Now that's not X anymore, right? That is T. So the 45 degrees is going to get plugged into the top equation here for T. And now, since you know T, you actually want to solve for X. Now to do this, it's not terribly difficult, but it takes a little bit of algebra practice here. You'll plug in for T, for example, you plug in 45, and now the thing you're trying to solve for is X. So just think about peeling off all the layers to try to get to that X. For example, if you know T is 45, let's try to get everything over to that side from the right to the left. For example, I think the most outside thing here in this equation is the 50. Let's undo that 50 by subtracting it. Once that's done, the most outside thing now to deal with, I think, would be the 25. Let's undo that. Think about how you're going to do that. And then the next outside thing is the sign. How do you undo a sign? We're in section 6.5, right? What's the title? That's a big clue for you. Once that is gone, just keep undoing the layers. Looks like you have to do this and get rid of that. How are you going to do that? And then last but not least, you need to get rid of this, and you'll have x all by itself. So go in that order. Just peel off the layers on the outside from the right-hand side of the equation, move things over to the left-hand side, and try to get x all by itself. When you get the x value now, when you're finished with that, bring it back to the chart. Once you solve for x, about what day is that? For example, if you solve for x and you get something like 93, let's say x equals 93, for example. I don't think it does, although I think it's pretty close for number 3. If you look at the chart, 93 is really close to here, which is April 1st. So if you count 2 days past April 1st, this would be April 1, 2, 3rd. Okay, so I would know that if it was 45 degrees outside, the farmer would probably start planting those vegetables around April 3rd. Like I said, that's not the correct answer, although it is pretty close, I think. But that's the idea. So number 3 would be done. And then basically just take a different answer for number 4. Now I want 65 degrees. Same steps, but now t is 65, solve for x, and find out what day of the year it is and what month and day. Number 5, same thing. You're now 50 degrees is t, solve for x. So for 3 and 4 and 5, your final answer is not just x, but it's also the month and the day. For example, April 3rd. And then you're all done. Not a terribly difficult project. It should only take about 15 or 20 minutes or so. But again, just make sure, a big clue up here, make sure your calculator is in radian mode for this to work out. Good luck.